All right, ladies and gentlemen, in this video, we're going to continue our discussion on inscribed angles, specifically with the goal of identifying what the inscribed angles of a circle theorem is all about and how can we utilize the inscribed angles of a circle theorem to find some missing angle measures or missing arc measures. So let's take a look first and foremost on the identification of this theorem. What we're saying in this theorem is that if we have two angles, specifically two inscribed angles, so angle ADB and angle ACB, if those two angles are congruent, okay, so if two angles of a circle intercept the same arc, then the angles are congruent. Just think about what happens here, right? We learned that if I have an inscribed angle ADB, it is half of the measure of arc AB. Well, ADB is half of arc AB, but take a look here. So is ACB, also should be half of it. So that means they would be congruent in measure. So let's take a look at an example here of how we can utilize this in some application. So it says find the measure of angle F once we know that the angle E is 75. Well, it's pretty basic here. We see that angle GEH, right here, GEH, all right, is subtend by arc GH, But so is angle GFH, also subtend to the arc GH. That means the measure of angle F would just have to be 75 degrees as well. So it's that basic in context, but you just may come to a point where you have a little bit more of different scenarios, but it's all the same. So just think about it. Let's say, for instance, if I went ahead and just said, well, here's a circle, same kind of scenario that is given to us here. Same kind of scenario that we have. These two angles would be congruent to each other. But we can also say, what if they gave us a value that this was 2x plus 2, and this value was, 4x minus 3, right? If those two angles were the angles there, and it wanted to know maybe what is the measure of that arc? Well, how could I go about that? Well, I know that these two angles would be congruent, so I can use that information to set up an equation to solve for x. So in this particular example, I could subtract and add, and x would equal 5 halves. So x would equal 5 halves in this case. Well, if x is 5 halves, if I substitute x into any of these equations, let's say here 4 times 5 over 2 minus 3, it ends up being 4 times 5 is 20, 20 divided by 2 is 10, and 10 minus 3 equals 7. So that means this whole angle actually equals 7 degrees. So this angle is 7 degrees. Well, how does that relate to here? Well, if this angle is 7 degrees, the subtend or intercepted arc is double of what its inscribed angle is, so it would be 14 degrees. That's how we can kind of utilize it in a different application as well. On to the next one.